right, about to go Dr. Bear on y'all. What's given, what do we need to know? I heard y'all doing fertilizer calculations the other day. Were you in that class as well? You're not in 1600? You are though, huh? Practical applications of ag. All right, what's the first thing we need to figure out?
How much air dried soil do you need?
How much air dried soil do we need? Pots per experiment. And 15 pounds of soil per pot. How many pounds of soil do we need for the whole experiment?
9,675.
I concur.
Caden? Check. What was the value?
9,675.
Like that percent subway. You're like, oh, hey, yeah, I want a foot long hot shot on wheat. Oh, what cheese would you like on that? Pepper jack, want it toasted? No. Cheese is that again? You said toasted, right? No. Pepper jack. I did not want it toasted. All right. What is the next most important portion of this problem that we need to know? The what? Okay, the recommendation. So we know, we got N a little bit later, but we got P2O5. We need 20 pounds per acre. K2O is 100 pounds per acre. And nitrogen is 75 pounds per acre. And the reason I gave you the nitrogen last is because that's just going to be a regular recommendation. We're actually going to choose that value. All right, so how many, what you got, Joseph?
I was remembering how many grams are in a pound.
Well, we know how many are in an ounce. Ounce, yeah. 28 and a half.
Yeah.
454 grams in a pound.
Yeah, 453.6.
450, right. All right, where are we supposed to go next after this? How my video's looking. Pretty good.
We're told what materials to use for each recommendation, so.
Okay,
it's kind of
and so which ones do we need to use?
It looks like 330012S for nitrogen, 0460 for phosphorus, and then 005217S for K2O.
All right, so what are we gonna do first? Which one?
P205.
The P2O5, because we're already gonna get some nitrogen from that, right? So we can just go ahead and say this is in 1 pound of 0.460. There are 0.46 pounds P2O5, and this gives us what is it? 43.48. Right. Okay. this. Which one's next? What's that? You wanna do the K2O?
As well.
Okay. And so what are we gonna do here?
100 divided by 0.5 is 2.
Okay. And 1 pound. All right, everyone pretty close to caught up? What's next? Okay, and so what are we gonna do here?
$227,
200, is it even?
227.67.
And what amount is this for?
2 million pounds of soil.
So this is, but this is for an acre, 2 million pounds. So assume the mass of the acre for a slice is 2 million pounds. That's the next most key integral part of that. Everyone tracking and following? Okay? What is this value? What is 227.27 divided by 2 million? You got 3 zeros in there?
Yes.
1. Everyone agree? Everyone see how we got this? Why this is now pounds of fertilizer per acre. But now we are at pounds of fert per 1 pound of soil. And so let's go ahead and do the P2O5 and the K2O. 4 zeros in this one.
And then
How much sulfur did you add?
Some in there.
Does it ask for it? Does it ask for the sulfur?
I don't think so.
And then,
It's too much to work over there.
It's 12 pounds.
12 pounds of sulfur is what goes in that batch? How'd you get that?
I was just doing it like the other way. 100 pounds. And then 75 pounds.
You would actually take that, you would actually get the sulfur content from the 227
Okay. Yeah, yeah.
times 0.17. Is that what that came out to be? 227 times 0.17 is?
I think they're defined differently.
Okay.
Thank you.
That's fine. All right, what we get for this K2O?
4 zeros. And 9.
Is it just rounding?
yeah, it's just around.
It'll be fine, especially at that small amount. All right, sir, everyone good? Everyone at least following, we got to this very small number of pounds. First thing we need to do is find out how many pounds we need total. Next, we're gonna look at the rate so we figure out how much fertilizer goes in 1 pound of soil. And that's important. So it's easiest to do it this way. Once you get down here, once you get to this 0.0011 pounds of fertilizer per pound of soil, you can get anywhere. It doesn't matter if it's 2 pounds or 200 pounds. It doesn't matter if it's 200.35 pounds. It's pounds of fertilizer per pound of soil.
Do you recommend us go ahead and writing that down on the test? Because
What?
I just left the number in my calculator because it was in scientific notation and then multiplied by that. Or should we actually put it down per pound or just go to the batch?
I'm just looking for you to get the right answer.
Okay.
If you don't write it down somewhere and you get the wrong answer, I can't give you credit for it. And you're gonna have like 24 hours to take the test, so,
24 hours.
yeah. What's up?
It's online.
Somewhat. It's a 24-hour take-home exam.
It must be
Just
bad,
completely shattering everything that anyone's ever done.
It must be bad if you let us do that.
Not saying.
It's not saying no, so.
I feel like y'all will appreciate having the 24 hours.
Thank you.
Yeah. Yeah. There was a little bit that came out of this too. There were some students who took in soil chemistry that were like, you know what, I actually did learn, I actually know something. This isn't just to be mean. The goal isn't to be mean. The goal is so that you like have the opportunity to express yourself without the stress of having 2 hours and knowing that you got a math problem at the end that's probably gonna take you 40 minutes. Right? Because that sucks. Because in the real life, you'll have as much time as you, well, put forth to it, unless you want to do your fertilizer calculations the morning you're spreading. I think once y'all see it, y'all will be like, oh, okay. All right. Okay, so we're all down to this 1 pound of soil. Haley's got just this big. Plus with the 24 hours, like you can put it off. I wouldn't recommend it though. I would not recommend that.
Wait until,
What's that?
wait until 11 at
Would
night.
not. But also at the same point in time, it's not gonna be a 1 week exam, right?
Yeah.
Is there a time limit on it?
What do you mean?
24 hours?
24 hours.
Okay.
I'm
I
gonna,
didn't know if you were gonna open it 24 hours, but then, well, we could take it during the 24 hours, but during that time, we could only use like an hour and a half. Then it shuts us off or something.
no, it's gonna be a Word document. I'm gonna email it,
Okay.
I'm gonna email it, and then you get 24 hours to complete it.
Just kinda like turning like an assignment, but it's in there. I got you.
Nobody else ever asks this stuff. I'm the dork that always does, but if it's take home, is it technically supposed to be closed book?
No,
Okay. I just wanted to ask, cause
You're good.
my conscience would bother me.
you're okay. That's
In the real world, you can use it.
because in the real world, you can use them, right?
In the real world, you don't ask questions.
You just do it and don't say anything. No, I would have addressed it as that it's open note, like Ally and William have had my classes. And I want you to have access to everything, because there's a lot of information that goes into answering these questions, and you can't just like memorize all of that stuff in the notes.
I now trust Casey more than anyone else.
What do you mean?
Casey's the most trustworthy person in here.
He's the only one that's gonna ask that question.
Don't worry, I would have addressed it, and I would have said that it was open note. No, I remember, for the PhD comps, I had 24, every committee member, there were 5 committee members, and everybody got to give you a 24-hour take-home test. So imagine taking 5 24-hour take-home tests in a week. And so I get to like the next to the last one, and half of the take-home test is closed note, can't use anything, and then the other half is open note. I had to finish the closed note one first. It was questions like if you had a candle that was like 30 minutes, you had 3 candles and they all burnt for 30 minutes or an hour or something. You had to figure out how many candles you needed to, I don't know, something.
When did you get your PhD in again?
Plant and soil sciences, candles. Candles, right? No wonder this guy's making stuff up. But it was like, which one weighs more, like a pound of this particular type of coin, or half a pound? I don't know, something of a different type of weight. Like which one weighs more, a silver dollar or 4 quarters? Type stuff. I don't know, it was something weird. I was like, just to see, I was like, what the no, dude, you don't give me no information. And one of them was compare and contrast these 3 different types of statistical models. Like basically brain dump everything you know about statistics. And I was just like, they all are models. And I don't know anything about that. So like 5 of those in a week. Just brain dead by that time. When I was done, I was like, I'm never gonna make it. I just like put my hands on my head and I just cried. Like literally tears falling on the desk. I was like, I don't wanna be this smart. I don't wanna be not having any of this. I digress, Dr. Baker. Okay, so we know that we gotta find out how much soil we need, and then we also need to figure out how much fertilizer that we need. And we're gonna get that down to pounds of fertilizer per pound of soil. Everybody follow along with that? Because I'm gonna have to erase some of this because there's not enough space. And I'm also going to work backwards so that I don't have to rewrite that. So just follow along. I'm gonna work back towards this way. All right, if we know that we need 0.0001 pounds of fertilizer per pound of soil, how many grams do we need per 1 pound of soil? How many?
For nitrogen, it's 498.5.
see if I can do it this way. How about this? We're coming backwards. That means that there are,
That's per batch, sorry,
oh,
that's
you
not
got the,
per.
you did the whole per batch. We know that there are 454 grams in 1 pound. Remember, I'm working from this way to this way. So how many grams of this nitrogen fertilizer do I need?
0.499.
Yeah, I got point zero. Yeah,
Yeah, sorry, I read that wrong.
My soils class will never let me put another wrong calculation on the board again. This is 0.0.
4994.
This one?
0.99.
Pepperjack, not toasted. All right, how about for the P205? Cause this was I'm just gonna write UAS. And this is gonna be CSP, and this is Sulpo. What you got for me, Caden? You got a number?
On, P205,
Yeah.
100, 9534.
Everyone agree? All right, who's got a value for K2O for me?
0.044.
Karen, extra decimals too, so if you round it, it's
0.0.
0.44.
You round it.
Oh yeah, my original decimal place was 9.96 instead of just 0.9 or 0.0000.
All right. Everyone get the same values. It's okay if it doesn't round the same. Is it close? It's
Yes.
all rounding. It's okay. It's perfectly fine. I'm concerned with the mechanics. I don't care about the value. I'm concerned with the mechanics. All right, what's next? Multiply it times,
18 pounds per pot.
okay? That's how many pounds go in the pot, right?
just an extra decimal place. I'm doing it a little bit different, but
Perfectly okay. That's why I like that's why I'm flexible enough, because everyone's gonna do it different. I'm concerned with the mechanics. Can you get to a very close enough answer? Cause Jackson rounded up? Somewhere in here, you rounded this,
That 0.00009, I had it as 9.6 instead of just 9.
okay? And that's just all based on how you did the math, right? Like
Yeah.
you just did the math straight through in your calculator. Maybe makes a difference. The mechanics are still the same. I like using the small numbers because then you can multiply back up and it comes out to a more realistic amount. So imagine trying to do this in 100 grams of soil in a urinalysis cup. Like crushing urea and literally weighing out sprinkles. All right, we got some values for this. 0.7491 grams per pot. Sarah, you got a number for me somewhere?
Sorry?
You got a number for me somewhere?
Oh, for that one?
Any one of them.
Okay, just a second.
This will be grams, right?
This would be grams.
For the second one's 0.40,
0.40,
no, 14, 1.4.
0.14 grams per pot.
Get something different for nitrogen, but I'm not.
Okay, well, what'd you get for nitrogen?
I got 0.9 grams per pot, 0.936, but I did it differently because I multiplied by the total first and then divided by the 645.
should be the same.
Should be close to the same. Let's finish this part out first, because I want to address something else about potentially doing this pot study. If someone got a number for K2L for this 0017, 0052?
0.66.
God bless. Everybody pretty close, somewhat similar? If you were to do this by batch, you probably wouldn't do the nitrogen this way, but if you were to do the phosphorus, you would change this to 10,000 pounds. And then you would do this equation times this, but instead of the 15, you would do 10,000. So you would add this as a batch. This one's gonna be might not be this small down the road in my exam. I'm like thinking like how I'm supposed to make this question worth it. To test the mechanics.
What make us make a batch first and then calculate per pot?
I mean, and then all you would do is calculate it from the batch. So the reason we do the 10,000 is, are you gonna get exactly 9,675 pounds of soil perfectly in each one of those 645 pots? If you've ever worked around soil, you would know no. You might not even get it with the 10,000 pounds. That stuff goes everywhere, especially it's been air dried, it's been ground, it's dusty. Also, it's miserable and you're weighing and it's close enough. For our case, let's figure out how you got this 0.09 or 0.9. How are you a quarter of a gram off? So you got 0.0011 converted into grams.
I got that we needed 1.09
that's gonna look like 9675 times 0.049994.
Yeah, so I was close to that when I divided by nine,
Okay.
675.
The mechanics though, right? And round it. Grams and pots. So this is why you don't go into horticulture either. Agronomy. You call the fertilizer truck up and they come spread it for you. We're gonna plant it, we're gonna fertilize it, pray for rain, we'll see you in September. Go fishing. Everyone got the mechanics of this down pretty good for the most part? Oh, that's gonna be, oh, y'all are gonna hate. Cause how do you test all of that in one problem? Alright, but the mechanics are there. And just as a question, a prelude, so to speak. Been hanging around there for a while. Let me listen. He was asking about the ASVAB. He said something about the ASVAB. I was like, I hadn't heard the ASVAB since like the 90s. I took the ASVAB when I was in high school. Did you have to take the ASVAB?
It's the Army like entry test.
It's basically so they can see if you're smart enough to fly the jet.
Tell you what you're good at.
They tell you what you're good at.
And
So,
then you send recruitment letters.
what's that?
Then send recruitment
And
letters.
then send recruitment letters. And so I got like a 117 GT score. It's pretty high. I go in there and I'm like, I want to be infantry, but you only need like a 95 to be infantry. And they're like, are you sure about that? And I was like, yep, sign me up. And sure enough, they didn't ship me off to basic training. They said, write his name down. There's a sucker born every minute. All right, let's revisit this for a moment, and we know that we need 75 pounds of N.
That was a bit
Really good at this.
20 pounds P205,
When you have these steps to follow, doesn't have to be.
and 100 pounds A2O.
That's the same thing.
What's that?
So that's the same thing.
It is.
Okay.
It is. I'm setting up the second part. How could we have made that problem? How could we have made this a lot easier?
25, yeah.
Okay, so we could have just brought this up to 25, and then our ratio would be
314.
314, and then we could have made a blend that would have met all of those soil test requirements for the batch. Sarah's eyebrows got really frumpled.
That's what I do when I try to figure out stuff.
So we would have just made this up, we would have just brought this up to 25, and this would give us a 3, 1, 4. And so then we would make our blend, and let's say we want to make a 15, 5, 20. How many pounds of N do we need?
75.
How many pounds, now we're into the blend part. 1 ton blend. Spell it right. What do we need to do now?
The
45.45.
rate over analysis.
How much? No, we're making the blend. We're making a 1 ton blend with a guaranteed analysis. This was the ratio. And then now we're making this blend.
45.45.
How many pounds of nitrogen need to go in this blend?
300.
15% of this 1 ton blend is nitrogen.
Oh, yeah, no,
Okay.
I was thinking.
You're good?
Yeah.
So we need 300 pounds of N. Man, this video is gonna be fire for y'all. 48 hours. And so how many pounds P2O5? And then 400 pounds of K2O. And so then we would make the blend, and then we can apply that fertilizer back to a batch. Because we're gonna figure this out for how to meet the recommendation for 1 acre. And 1 acre is the mass of the acre furrow slice, which is 2 million pounds. All right, the good thing is that I made this pretty easy because there's no two element fertilizer sources. So this is gonna be divided by 0.52, this is divided by 0.46, and this is divided by 0.33. And our values are going to be, so we're going all the way back, Sarah, where we're making the blend as a 1 ton blend.
So this is just another way you can do this problem.
What's that?
It's just a different way you can do this problem, or is this something?
I'm adding to it,
No.
so that way that it's there for when you need it. Riley's got this really confused look on his face. Yeah. This look. I'll rate my professor is about to go right through the basement. How many pounds of 330012S do we know? I got this 33 from these values on this paper, right? How much?
Portland.
How much?
109.1.
109.1.
900.
How many pounds of P2O, how many pounds of this CSP?
217. 4. And 769.
I swear you'd think I'd know how to do this. What we got, William? What's our math? I'm at least gonna get the decimal right. I got that part.
I kind of Jimmy winged it. It's 1895.
Is that total?
0.7. Yeah.
Okay. That's how many pounds of fertilizer material are gonna go in this 1 ton blend. All right, so if we keep on going, so then how many pounds of this blend do we need in order to meet the soil test recommendations? We know that we need 75 pounds of N per acre, 0.15 pounds of N and 1 pound of dirt.
It's 500.
500? So we need 500 pounds of this material. £500 over 2 million pounds. So we'll do pounds of dirt, pounds of soil.
.00025.
How many zeros?
Three.
3? Do we need to calculate the phosphorus and the K2O? No, because we made the blend in the appropriate ratio to meet all of the soil test recommendations. We made the ratio appropriately to meet all of the soil test recommendations. And if we remember correctly, our batch was, we wanted to make a 10,000 pound batch. It was 96.75. Well, then we would just do 0.00025 pounds times 10,000 pound soil. That value will be what number for me, Joseph?
2.5.
We need 2.5 pounds of 15,520 per batch. What's up, Casey?
Dumb question, but where did the 300, 100, and 400 originally come from again?
Right here,
Yes.
15% of this 1 ton blend
Okay, sorry.
is
I didn't-
nitrogen.
I didn't
So
see the
so it's either 2,000 times 0.15 or it's 15 times 20. And remember, I mentioned that there are 20 units in 1 pound. Technically, this is a unit. There are 15 units of nitrogen in this blend, and each unit is worth 20 pounds. So you can either multiply 2,000 times 0.15, or you can multiply 15 times 20.
15 times 20 seems easier somehow.
I just double it and add a 0. Bing, bing, bing.
So what do you mean by to see that you met the soil test recommendations?
What's that?
How do you see that you met the soil test recommendations? Like from the 5,000 or 500, what are you comparing that to? How do you know you?
You talking about right here?
Well,
how-
yeah, like how do you know you met the soil?
How did I know that I met them? So that we know that in, we know that in 500 pounds of FERT, there are 0.05 pounds of P2O5. What does that math?
So we just increased it.
Point zero,
And
point zero
the
five,
soil.
500 times 0.05 pounds P2O5.
25.
25. We solved this problem before we ever started because we made the blend in a 3:1:4 ratio. That's the purpose of making the ratios, that I get all this done at one time. I don't have to do the math the next time. I know that I'm always going to meet that soil test recommendation. So I didn't have to do this because I knew that the blend was in the appropriate ratio. Riley?
Just multiply that 2.5 by 4,540, put it into grams.
That's going for the whole batch.
And then divide that number.
I don't think y'all are gonna need the 454 grams.
So for the guaranteed analysis, that's just changing the ratio? Like, is it preferable to have a 15,520 versus, okay, something else?
I mean, we could have had if we did this by 6, we could have had an 18,624. Probably wouldn't have fit in that 1 ton,
Gotcha.
all right?
Yeah, just trying to max out as much that you can fit. Okay.
Yeah, because I mean, if not, it's just gonna be paying for filler.
Okay.
And you have to apply more fertilizer and less trips. So it's like Joseph was like, oh, what, oh, yeah, okay. The more material you have in here, the less trips across the field technically you need to make. because you're actually putting more, a greater density of material on the property in a 1 acre than if you were to have, if you had a 9/312. You would have to apply almost twice, a little bit more than twice as much, right?
Right.
So you want this value to be as high as possible and still make that into 2,000 pounds, as close as possible,
Okay,
right?
thank you.
So that way you apply less material. Because how many pounds of material, if we needed 75 pounds of N, and the fertilizer blend was a 9/312, how many pounds of fertilizer would we need? Rate over analysis.
What'd you say? The
500, or 75 divided by 0.09.
833 pounds. Is that right?
Yeah. Would you rather apply 900 pounds or 500?
500 pounds.
500 pounds, right? So that's kind of the thought process on there. That video is gonna be key. Because I'm testing all of the mechanics in here, except for the grams. I'm gonna take the gram part out of that.
I mean, this,
You look at it, you already know I'm coming with something, don't you? Damn it. But it's gonna test all of them. What's up, Casey?
this videos you're gonna upload that.
Yeah, make it to not.
This must gonna be really bad.
What's that?
This must just gonna be bad.
It's not that it's gonna be bad, I'm just gonna, this is Dr. Bear type stuff.
There we go.
15,500,
But you know how to do all of these, it's testing when to do them and how to do them.
That's close to 2,000 pounds as possible. So we're just talking about too, like, you can change that rate, but.
How do y'all feel your math skills have increased over the past 2 weeks?
So like, trying to be right under 2,000 pounds.
You good now, Jackson?
Oh, yeah.
Jackson got in here 2 weeks ago, and he was like, wait, there's no math in that.
And we can find some try that. Just trying to find like a good bit. Except that's what I was like, it's on the part where
That's
I
why you
would
were
have
asking
something.
about if it was $9.
Exactly.
That's what I had a problem with when I did this. I was like, geez,
All right, so the exam is gonna be somewhat like multiple choice. There will be a little bit of fill in the blank, mostly like discussion, describe what happens when you apply lime in reference to blah, blah, plant uptake.
Your phone's about to die.
Oh, okay. What role does pH dependent charge have on nutrient uptake? What happens if the soil is too acidic? What happens to the indirect and the direct method? That's why it's 24 hours. Because other than that, because if not, you two already have the answers, and that's not fair to the rest of the class. And then also, they haven't had me for this for, a whole semester.
I've had you for like every class.
For every class. That is one of the drawbacks of only having one person to teach this particular major. In animal science, they at least get to break it up. But, sorry. I wish they'd hire another person, that'd be amazing.
The one pro is you know your lessons are not gonna complete though.
There's always a silver lining.